Electrical Systems Test 11 from Test 11 handout on lighting systems. And when replacing halogen lights, the technician should never touch the glass surface of the new bulb with his or her bare hands. And it will blow that bulb if you get any skin oil or anything along here. What both an aiming screen and a headlight aimer are required to aim headlights. That's not really true. If you got one or the other, you're okay. You can make an aiming screen, but you need enough room to have that aiming screen far, 25 feet from the car typically, if you're going to do it. The farther you get away, the more your lights are going to, a little bit of angle here changes a lot out there. Anybody that's ever run a spotlight in a play knows that. When they're using an aiming screen, the technician should align vehicle headlights with a mark that's about 50 to 75 feet from the vertical screen. That's false. We're not going to do that. We're going to go about 25 feet according to what the books I've seen does. Some headlight aimers align the lamp centers with the rearview mirror, which is usually located in the vehicle's center. That's not true either. Some headlight aimers determine the geometric position of the headlight faces in relation to each other and gravity. Well, wait a minute though. Think about that. Think about what that headlight aimer you were doing the other day was, that hoppy one. Now read that question again. Some headlight aimers determine the geometric position of the headlight faces in relation to each other. Alex, remember when you were looking in the little mirror and lining up the little yellow and black stripes? That's what that's talking about. You see, the angles have got to be right, or those on both lights, or those won't line up. You remember how you were changing that like that? Okay, and what about the other one? Gravity, what's that?
That's the bulb.
That's the bubble. Remember the bubble? So that's gravity, and that's in relation to each other. So that question is true. Okay, you got it. That is a true question, or true statement. The relay-controlled headlight switch is a light-duty device which activates a heavy current relay. Did I skip 6? Vehicle headlights can be controlled by either a relay mechanism or a switch. And that is true. And so is the next one. The relay-controlled headlight switch is a light-duty device which activates a heavy current relay. You got a light-duty device operating something that's going to pull a lot of amps, you're going to be using a relay every time. The headlight switch is a heavy-duty current carrying device that can be easily located anywhere within the driver's reach. That is weird that the answer key would say that one is false, because nowadays the headlight switch is not. But on these older headlight switches, like this one right here, that is made to carry heavy current. You know what I mean? So this thing, it says that it's false, but it's actually true. Incidentally, somebody's going to need to put a fuel pump in that Dodge that y'all did the front end work on, because the fuel pump crapped out on it. So, wonderful. Ain't that great? Okay. While procedures for...
What else do you want?
Huh? Oh, just pick one. I don't care on that question. That's really not a very good question. And Haldeman didn't do this one, so I can't blame him. While procedures for replacing most lighting system components vary, the procedure for replacing headlight switch is usually the same. That's false. Headlight switches are all over the place. Upon application of the brake pedal, brake switch contacts close, thus energizing the brake circuit. That's true, isn't it?
Yeah.
However,
For most.
that's not exactly true on a lot of cars. If I mash the brake, like that Impala that we work on that Jim Crudop drives now, if I mash the brake on that one, does the brake light switch turn on the brake lights on that thing?
Doesn't it just send a signal?
Huh?
Doesn't it just send a signal?
What does it do? Positioning switch?
Well, the brake pedal position switch, it's actually talking to the the body controller, and the body controller responds to that switch and turns on those lights. Now, a lot of these controllers, when you see controllers, if you've got switches, like let's say you've got multiple switches, like cruise control or something like that, and this isn't always this way, but a lot of them it is, or on some of your wipers and stuff, they have got various different resistors in there that are shorting a reference voltage down to different levels so that it'll know what it's supposed to do. So that computer is actually watching the reference voltage, and if a current dropping through a current dropping resistor, so you're not actually shorting something with current. So you got voltage out there, but you got no current. So when you turn through these different intermittent wipers and all that, basically you're going to be changing that voltage, and that's what cruise control is. On a cruise control switch on a Ford, if you mash off, it's actually gonna short that blue wire with a black stripe that's going to the module, it's gonna short it to ground. When you push on, it shorts it to power. When you push your coast or your resume or your set accelerate, it's got 3 different resistors. And it knows that way. So if I'm gonna check cruise control on a Ford car, I'm gonna go to that blue wire with a black stripe. And I'm gonna go in there, and if I see 8 volts, what do I know? I know that the cruise control module has got power and ground. I don't even have to check power and ground of the cruise control module, because if it didn't have power and ground, I wouldn't see 8 volts there. It generates the 8 volts and it sends it out of the switch, don't you see? Okay, so I don't need to fool with any of that. Now there are some other things I need to check besides that wire, but I'm gonna start with that blue wire with the black stripe. It's also a good idea to know you got stoplight bulbs that are not blown. If you got 2 stoplight bulbs blown, you're probably not gonna have cruise, because it looks for the ground coming through those bulbs to determine if it wants to do cruise or not. I'm gonna go to that thing, and I'm gonna say, go in there, I'm gonna have Joe, or whoever I have working with me, I'm gonna say, hey, look at him, let's go ahead and hit the off button. That 8 volts will go away. Hit the on button, it'll go up to 12 volts. Okay, now hit your set, accelerate, your coast, and your resume, you know, starting from the bottom going up, and the voltage changes all the way up. Then you know that it's the switches are okay. But what if I hit the button? What if I see 8 volts there? And I'm measuring out here at the module under the hood now. I can show you guys this. It's really important if you want to work on cruise control. I'm going to go out here and I'm going to measure that module under the hood. 8 volts I see. If I measure it and I don't see any 8 volts, then I'm going to look and see if the horn works, and I'm going to see if my airbag light's on. So you got clock spring issues. You changed the clock spring before, hadn't you?
Like that ring there, thing.
Yeah, under the dash, okay, or under the steering wheel, excuse me. All right, so anyway, and this question right here, I don't know what you're gonna do with it, it's kind of silly. Oh, incidentally, 10 is actually supposed to be a true question, but it's not always true on newer cars. There's 3 basic types of small lamp: square block, wedge, miniature, bayonet. That's okay, but you don't really need to know that. That's actually gonna be, false. Wedge lamps are gripped by the metal fingers in the socket, and that's true. Miniature bayonets look like a little small tail light and stoplight bulb. Bayonet's the one you push in and turn and click, and so that's going to be true. Small lamps are used in courtesy lamp systems, and that's true. And small lamps are used in dashboard lighting systems, and that is also true. Okay, you tried to hurry through that. How are you doing?